Oh, so you mean the one dealing with interval notation? Okay. Because that's not any one, right? What does it say? Which ones do I have to do interval notation for? Inequalities. What does inequality mean? Less than, greater than, that kind of stuff. You with me?
That's C or C or C. There's only one in there.
I thought there was two.
C. Oh.
H. Say and H. So C. Well, I mean, if your whole question is, I mean, just to remind you guys, if I had x greater than or equal to -3, what would that look like graphed?
A solid solid.
Oh, we've already forgotten. Shit.
Isn't it
You got the arrow pointing in the direction you want to go.
True, that's right. So I'm going to shade up. What symbol do I put in there?
Oh, yeah, I forgot what you were doing.
Because it looks like the letter I, which stands for include. Parenthesis looks like half of an open circle, which means exclude. Oh, shit. So why did we start doing that weirdness? Because now to put it in interval notation is easy. What symbol do I put on -3? That one. Up to infinity. What symbol do I always put on infinity? Good, because if you put that on it, that means you made it to infinity. You won. Maybe, I don't know what that means. You fell into the black hole garden. Alright, that's kind of a minor point, but if you put it that means you can go pick it up. There's infinity. No, take one more step. No, it's not infinity. That's interval notation. I like it. So those, you should be able to, solving them is exactly the same as solving equations except for one thing. How do you solve this? Yeah. Yeah, true. So that'd be just like this one, except there would be parentheses.
Always we divide by like negative, we change.
Exactly. Why? Because. What's up? Oh. Look, real quick. Which one looks more like an L? Which one looks like an L that fell over a little bit? That's less than. Less than. L, less than. Other one is greater than. Or the alligator crap, whatever. Do you know what the alligator?
Yeah, it's eating
Alligator wants to eat the bigger thing.
Whatever. That looks like somebody trying to do loser and they kind of, oops.
Yeah.
When did you change the sign? Or the inequality sign?
Here?
Yeah.
Okay, alright. Which one's bigger?
One.
Okay. If I divide by -1, which is completely legal, that becomes 4. That becomes, which one's bigger?
4.
4. What happens?
Changes.
It just happens. Because when you multiply by negative, it changes what side of 0 the numbers are on. So whatever was smaller is
I
now
didn't see you put
bigger.
-2x is less than 6. I just saw -2x over -2. You can
Yeah.
put that up there at the beginning.
So yeah, since we divided by negative,
Yeah.
Maybe. I don't know if it was one of the questions, but you think you can go over the cubes? Because I'm not really sure how to do
Sure.
that. Like the little cube, big cube.
so normally my advice for people is the 10 minutes before an exam, don't look at any math because you will only freak yourself out. You look at, you're like, I forgot. What else did I forget? Oh shit, here's the exam. You know, but this is the one thing I'd say you should do a couple of right before the test starts, which is cubes, because it's just knowing how to put it together. The other factor you can kind of sink your teeth into, 9 is 3 and 3, and it makes sense a little bit more. This one is just, do you know where to put stuff? So like, let's do one that works, Jeff.
The soap, right?
Soap, yeah, you can use soap.
But I forgot what where it's supposed to go. I knew the thing, I just didn't know where.
I'll show you. I'll do this problem without soap, and then I'll remind you what soap is. Because I don't like using too many of those things because it removes you from why it works. It's just a kitschy little thing to remember. But anyway, it's just me. So how do I know this is a cubes?
Because it says cube.
If I would have put a 25 there,
No.
it would not have been cubes, no matter what these guys think. That can be broken up into three parts, that can. Okay, so then you do it. You break it into three.
3W.
3W, 3W, 3W,
4Y.
4Y, 4Y, 4Y. Now that we've talked about cube roots, maybe even these numbers will be easier to remember.
Yeah.
Cube root is 64. We talked a couple of times, 4. So when you see it in the cubes, you break it up into 4s. If you saw it in the squares, you break it up into 8s. 64 is a neat number. It's a cube and a square. All right.
3W.
Yeah, so you got a little dude, big dude. So the little dude goes
3W plus 4Y. Oh, that's what I did.
So here's got to go
6W.
9W
and
squared.
9W squared. And just to check, what is 3W times 9W squared? Yeah, so that's why. If you put one piece there and the other two pieces there, altogether they make the three pieces you had originally. One of each, two of each. So that makes sense. So the end would be what? The other,
16Y squared.
and that's where 64y cubed comes from.
That's fine.
Plus, so it doesn't screw with that plus.
Minus 12.
Yeah, minus cancellation term, right?
Yeah, opposite sign. Why is it minus?
That's why.
Because what's the job of this little dude?
To
To
cancel.
cancel the shit you don't want. So it's got to be the opposite sign. Minus 12
WY.
WY. Just whatever's here and here, slap them together.
I tried so hard. No, that's where I went blank. I was like, I know it's soap, but what the hell is soap?
What's really weird is the minute you go above cubes, unless they fall into very specific patterns, you don't have a general backwards formula for them, and not a nice one. Alright. So, that's the thing I'd say do a few of. Maybe with the guidance of the factored handout it gave you, so you're actually doing them right. Right before I give you the test. Normally I don't like students doing that, but this is just so easy to leak out your brain. Why do I know it so well? Because I do it every semester. That's really why I know math as well as I do. Yeah.
Can you go over graphing inequalities and like shading the sides?
Oh,
Oh, yeah. No, with the
No, like with the
Oh, the-
graph,
okay,
like
okay.
the two lines.
two systems of linear.
Yeah, you gotta fuck that up.
Fucked it up? Alright, so I'm going to just cut to the chase. If I don't give it to you y solved, you've got to solve for y. So you can graph the line, right? We're just going to give it to you with it's already solved. Alright, so what do you know about line number 1?
It's negative. The slope is the y-intercept is negative.
Okay, y-intercept is negative 4.
The slope is
I lost everybody. What happened? Up 1,
right 2.
over 2,
Up 1.
up 1,
Right.
over 2, and that's enough. What kind of line is it going to be?
Solid.
Dash.
Solid line.
Solid.
If you see a line,
It's a solid.
you draw a line. What's the hard part?
Shade.
I got you. Alright.
then plug it in? Yeah, you will. With the 2 points, like you had a point, and then we had 2.
No, I didn't give you one where you had to create your equation and then graph it. No, I didn't. No. So how do I tell which side to shade?
We need to take the point and put it.
No, 0.
Yeah, if it doesn't go through 0, 0, I'm allowed to use that. So when I plug a 0, 0 in, is 0 bigger than or equal to 0 minus 4?
Minus 4.
Is 0 bigger than negative 4?
Yeah. No.
Yes. So that works, which means everything on that side works. Does that make sense?
Yes.
Because the whole idea of drawing this line is it's the dividing line between answers and not answers. So how do I check to see which side to shade? Well, if one works, they all have to work. That must be the side that works. There can't be like, well, this point works, and this point works. No. It's one side or the other. That's what this is. It's just one direction.
So
then I would go this way for that. Now on top of that, you graph the other line. What do we know about it?
5. Y-intercept is 5. Bottom. Down.
down.
Now
3.
1, 2, 3.
Go 1.
Over 1. 1, 2, 3. Over 1. So here's what kind of line?
Dash. No,
Dash.
dash.
That big. And again, I can plug 0, 0 in because it doesn't go through it. So is 0 less than 0 plus 5? Is 0 less than 5?
Yes.
So then I'm going to shade.
This.
If it didn't work, I would shade the other one.
Okay.
If it doesn't work, that must not be an answer. If that's not an answer, none of these are answers. Right? It's like Giants fans and Jets fans. Red Sox fans and Yankees fans. So I'm going to grade. Shade this way. Where does the shading agree?
Right there.
In this quadrant. So that's going to be all these points in here. Every point in here works in both.
Gotcha.
Every point in here
No.
doesn't work in either. So in real life, this would be like, this would be my safe place. Because maybe this is electrical load and this is weight or something. So if I'm over here, the thing's going to blow up. From there, it's going to fall down. If it's there, as it's falling, it's going to blow up. This is real. I mean, this is actually what we use. This is restrictions, and I figure out where's my safe place. So then if I'm like, I plotted where we are, we're there, they like turn everything off.
We do have like 6A. We should like solve for Y first.
Yeah, definitely. Yeah, I just cut to the chase here. You should be able to solve for Y. Solve for Y, then do everything we just did. If it's just one equation, thank God, you just have to do one. 2, you got to put them on top of each other.
And so the answer is just where they like.
Yep, that's the answer. So where's your answer? It's just you shade it in darker where they agree. That's why I first only did little arrows, so it's not too much crap to look at. Yes.
Can you go over 4E? Is that the method where we like switch them together?
Oh, I have a question.
What is that? Oh, that's mine.
1E?
No, 4E.
4E. Everybody else need their stuff? Anybody else not get their stuff back? So 4E. Correction? All right. I'll keep you straight with all this. Oh, okay. So what methods do I have to solve a system of equations like this? And I don't say which method. You could use either method you want. I would maybe not do this graphically. That'd be a little much work. But what algebraic methods do we have? I think I heard somebody say solve for y. I might have just used one of the voices in my head. I could solve for y and then use substitution, right? That's one method. Or it's kind of set up. What can I multiply the second dude by to kill the y's, for example?
5.
Yeah, I look for my coefficients of 1 because they could become anything. So if I multiply by, no, this is already opposite signs. So if I took the second one and multiplied by 5, what does it become? So now I can put these together.
-7.
Yeah, negative 7x cancels equals
7.
7.
Divided.
So x is
-1.
negative 1. How do you figure out what y is? Plug it in either way. Either way, yeah, for x and solve for y. I plug it in this one.
But if you were to do the other way, where you
Yeah.
can't use the equation that you use, you can't use that again, you have to use the other equation to plug the number back.
No. No, I'm with you. So, what you got to be careful about if you, now obviously this is not done, y equals, if you plug a negative 1 in here, it's 2, subtract 2, you get negative 1.
That's not what I was saying.
I know, I just wanted to finish that out. So if you solve this for y and you're going to do substitution method, the one thing you can't do is plug this into itself.
Yeah, that's what I was saying.
That's the one thing you can't do. Because you can't figure anything out unless you use both pieces of information. So if you take this piece of information, plug it into the other piece of information, together they'll tell you something. So then I get 3x minus 5 times,
2x plus 1.
because I know that y is this, so I can just replace y with it. So 3x minus 10x.
Plus 5.
Negative
5.
Negative 7x equals 7x is negative 1.
They call this method.
It's a system of equations. Oh, this is this is elimination. I think the book, I can't remember this book. Some books call it addition method. I call it elimination. Substitution. Because I substitute. Math people are very creative. You substituted. Let's call it substitution.
I have a question.
Right. Thanks.
If you're cubing something,
Yes.
and it's the variables instead of numbers, and it falls even, you just go like this.
Oh, cube root. Oh, okay. Let's do a couple quick fire. What's this? Yeah. And what's this? Yeah. So if I add cube root of x to the 15th, y to 33, you just do both of those at once. Because what's a cube root do to things? Cuts it down into thirds.
Multiplicative.
Also, this
Multiplicate,
should have been
I like
just x. If it's a 3,
Yeah, it's just be x. So the shortcut is 3 goes into 15, 5, 3 goes into 33, 11. So if it was a 3, 3 goes into 3 once. Yeah.
So then what if they don't divide like that? Like, because there's the one on practice test is 5 and 8.
Oh, and I know in the answer key I did it, I kind of showed more steps, but you remember the shortcut? The shortcut's beautiful. 5 goes into 8 once with 3 left. The way we say it is the way we write it. It's crazy.
Can I get the answer? The answer to the
Yes. Brandon, you need us to get that? The answer key?
Can you do the long division one again? Long division one again, because I wasn't here for
Oh, you went
So do it like what we did.
Okay, so then you rewrite it. So you would multiply x squared by x, or 3x. And then you'd have to multiply, yeah, those by x. So then you get 6x squared plus 6x, 9x. And then you smush, yeah, change the sign. Cancel out. And then you get 2x squared minus 4. Okay. 2 plus 2 minus 4 and plus 6. And then you change the signs again. Okay,
I almost made one that worked. How about that?
and then the first two get smushed. And then
Smushed.
minus 4. So that's the answer. And then minus 4 over all that.
That's
It's
the thing.
easy when you do it.
Yeah,
Of course it does. Of course it does. You just gotta sit there and agree. But what you gotta, as you watch me do it, you say, do you understand why I did what I just did? That's how you work a math class correctly. Don't just sit there and go, yeah, I could. Say, do you know why I put a 3x there? Do you know why I changed the signs? Do you know why I brought that down? You know why I did the steps I did? If you can't say yes, then no shit, you need more help. But it sounded like you were guiding me a bit, so it sounds like you know it pretty good.
Or you could also put plus minus there for
Yeah, that would be okay.
or minus.
Yeah. You could always just put plus and then put whatever that is over that. You could always do that.
Wait, so how would one look if it didn't have a remainder?
So, 7 goes into 8, wants remainder 1, right? Because 8 was 1 too big.
Yeah.
So this says that 2 was 4 too small. So if I would have put a 6 there, these would have canceled, right?
Okay. And then
So this remainder tells you how far off this was from having it go in evenly.
Okay.
Yeah. That's the remainder's job.
So if there's no remainder, there's
Then it went in
no
evenly.
remainder.
Which means that that would factor as this times that if there was no remainder. Yeah.
How identical is this practice quiz to the or practice test to the final?
I don't know. They both have algebra. You have to expect me to give you a silly answer. Yeah. This one's, I don't know. It's going to have, I mean, I can't really, the only thing that's going to be really, not really different, but definitely not the same is the word problems. You know I'm going to give you a long division. You know I'm going to give you factoring problems. So I mean, you know, I can't really change those up besides, you know, putting different numbers into the cubes. But, you know, the word problems could be triangles, it could be squares, it could be areas, perimeters, you know.
But, so this final is going to be longer than our regular test.
Yeah, because we normally only have like an hour and a half for tests. Starts a little bit early, yeah, starts at 7:15. So if you come at 7:25, it's not horrible. I have other ones that start an hour before we normally meet. So I'm continuously reminding everybody, if you come an hour late, I ain't staying an hour. You chose to not have that time, so I'll be here a little before 1:15. Actually, I'll be here in my office at 6:45, yeah.
So it's ninth grade.
No. Everything in parentheses is the class average.
Oh.
Yeah. This is what would happen with or without all the homework.
Okay, so you've already graded them. So that's
So this is not including homework. I don't include homework in the grade until the final exam because that's when people are turning in late homework and corrections. Yeah.
But if my homework has nothing written on it.
Oh, then you're fine. I give you full credit. I just didn't have time to look at it.
And do we make corrections on this last test?
If you want to, you can.
So I'm missing